Hello, this is exercise 6 of data structures and algorithm. In this exercise, we have two programs. First is linear search and second is binary search. So first, let's see the linear search. In this, it's a very simple logic. First, I've initialized two variables of integer type n and s. N is the number of is the size of array, and s is the element which we want to search. So first I've asked the user to enter the size of array, and I've initialized an array AR of that size, which is equals to n. Second, then I've asked the user to enter the elements one by one, and using a for loop, which goes from 0 to n. I've taken the input and stored it array of I. Then I've asked the user to enter the element the user wants to search, which is stored in S. Again, I've used a for loop which goes from 0 to n, and I've used if condition which checks array or AR of I is double equal to S. If it's true, then we have to see out that the element is found at the position of I plus 1. Here it's I plus 1 because we are starting from I from 0. So let's run this program. Uh, so it's asking for the size of array. Let's give the size as 5. And let's enter the elements as one by one. So 4, 6, 2, 8, 9. Now it's asking to enter the element to be searched. So let's search for 2. So here we can see it is giving element found at position 3, and which is correct because 2 is inserted in the position 3. So let's go to the another program, which is binary search. This is also a kind of search, but it is faster. So let's take its program. First, I've created a function called binary, which will of return type integer. This binary function has 4 parameters. First is an array, and second is the start of the array from where it's starting, the end of the array, and s, which is the element to be searched. Then I've given a condition: if n is greater than or equal to start, then only these condition will run. So let's see. Inside this if condition, I've calculated the mid equals to start plus n by 2, and I've stored this value in a mid, and I've checked if array of mid equal to s, that is the element to be searched, then simply return the mid, which is the index position. Else if I've checked if s is greater than array of mid. If it's greater than if the element to be searched is greater than the middle element, then using recursion I've returned the same function, but here I've changed the start and the end point. I've given mid as mid plus 1 and end is the same, and the element to be searched is still same. Else if I've given that if the element to be searched is less than array of mid than the middle element, I've again used recursive, and I've given as the start as start, but I've given the end as mid minus 1, and I've passed the s element to be searched as s. Else I've returned minus 1, which means the element is not present in the list. In the main function, I've taken two integers, n as s, n the number size of array, and s to the element to be searched. I've asked the user to enter the size of array, which is stored in n, and I've created an array of size n. Then I've asked the user to enter the elements one by one using a for loop 0 to n, and stored it in the array. Then I've used an integer l, and then I've used a for loop which goes from 0 to n, and I've initialized l equals to I, and inside this for loop I've used another for loop which goes for uh, uh, j is equals to I plus 1 till n, and I've checked if array of j is less than array of l, then l equals to j, and I've then swapped array of I and array of l, because this is done in order to sort the array, because binary search can only be used in a sorted array. Once the array is sorted, then we ask the user which elements he needs to search. So I've taken that input in s, and I've stored the result in an integer result, and I've called the function binary, passing the array and passing the starting index, which is 0, the end index, which is the size of the array, and the element s, which is stored, which is s. Then I have used a ternary operation where I check if result is equal to 1, cout element is not found, else we have to see out the element is present and the position which it gives. So let's check the program. So I build and run it. It's asking for the size of array. Again I give 5 into the element. So I give 5, 8, 2, 3, 1. So now let's check the element to be served. Let's give it 3. So it's showing that the element is present. So our program runs correctly. So let's this is the end of 6th experiment. Thank you.